Hello everyone. Today we will study multivariable probability function. First of all, let me introduce what it is. Let x1, s2, sn be discrete random variables. The multivariable probability function f is defined as the multivariable probability function f is defined as f of s1, s2, sn equal to the probability that s1 equal to x1. This is lowercase x. Those are lowercase x. s1 equal to s1 and s2 equal to x2 and xn equal to sn. That's how we define multivariable probability function. Note, if there are only two random variables, if there are only two discrete random variables, x and y, then the multivariable probability function the multivariable probability function f is called the joint probability function. If there are only two random variables, s and y, then the multivariable probability function f is called a joint probability function and defined as f of x comma y equal to probability that x equal to x and y equal to y. If there are only two discrete random variables, x and y, then the multivariable probability function f is called a joint probability function and defined as f of sy equal to probability that x equal to x, y equal to y. Now let's look at an example. When a coin and a die are tossed at the same time, the x represents the number of obtained heads, and the y represents the value shown on the die. Find the joint probability function. In order to find the joint probability function, let's find a sample space first. Sample space is the set of all possible outcomes. When we toss a coin and a die at the same time, the coin could be either a head or tail. And when we roll a die, the values shown on the die could be either number 1, 2, 3, 4, 5, up to 6. So together the outcome could be a head at number 1, a head at number 2, a head at number 3, a head at number 4, a head at number 5, a head at number 6. Or an outcome could be tail at number 1, a tail at number 2, a tail at number 3, a tail at number 4, tail at number 5, a tail at number 6. Next, for each sample point, we try to find the x and y values. For each sample point, try to find the x and y values. Here, random variable x represents the number of obtained heads. Random variable y represents the value shown on the die. So if an outcome is a head at number 1, x is 1 because we obtained 1 head. X represents the number of obtained heads. X is 1. Y is also 1. Y represents value shown on the die. If an outcome is a head at number 2, S is 1. X represents the number of obtained heads. We obtain 1 head here. Y is 2. Y represents value shown on the die. S is 1, Y is 3, S is 1, Y is 4, S is 1, Y is 5, S is 1, Y is 6. For the sample point, tail at number 1, X represents number of obtained heads. Here we obtain 0 heads. Y represents value shown on the die. Y is 1. S is 0, Y is 2. S is 0, Y is 3. S is 0, Y is 4. S is 0, Y is 5. S is 0, Y is 6. Next, based on this, we can try to find the support of X and Y. What's support of X? Support of X represents the set of all possible values that S could be. Here S could be either 0 or 1. When we toss a coin, we can get either 0 heads or 1 head, or at most 1 head. What's the support of Y? Y represents the value shown on the die. When we roll a die, the value could be either 1, 2, 3, 4, 5, or 6. So support of Y is numbers from 1 to 6. Support of Y is numbers 1, 2, 3, 4, 5, or 6. Next, find the joint probability function. In general, we can write joint probability function as a table. In general, we can write a joint probability function as a table. Usually write value of X in the column, write the value of Y in the row. So first of all, write down all possible values that S could be. S could be either 0 or 1. Next, write down all possible values that Y could be. Y could be 1, 2, 3, 4, 5, 6. Now in the sample space, we can see that there are totally 12 outcomes. 2 rows, 6 colors. There are totally 12 outcomes. The chance for each of them is 1 over 12. In the sample space, there are 12 outcomes. 2 rows and 6 colors. There are totally 12 outcomes. The chance for each of them is the same. When S is 0, Y is 1. That's one of them. We have one outcome here. S is 0, Y is 1. So the probability is 1 over 12. Next, when x is 0, y is 2, we have one outcome here. The chance is 1 over 12. Next, when x is 0, y is 3, we have one outcome here. Chance is 1 over 12. X is 0, y is 4, chance is 1 over 12. 1 over 12, 1 over 12. When x is 1, y is 1, that's one of the outcomes. The chance is 1 over 12. 1 over 12, 1 over 12, 1 over 12. That's the joint probability function of x and y. In general, we cannot answer as a table. But how do we verify if an answer is correct or not? So in order to verify an answer for a probability function, we can keep the following properties in mind. Note, let f of xy be the joint probability function of x and y. Then we have the following properties. First of all, f of xy is always between 0 and 1. Probability is always between 0 and 1. And also, the sum, if I take the sum for all x in the support of x, and take the sum for all y in the support of y, if I take the sum for all x in the support of x and take the sum for all y in the support of y, f of xy, the total probability must be 1. So the probability f of xy, probability function f of xy must be between 0 and 1. And the sum of all probabilities must be 1. We can verify here. Probability for every x and y is between 0 and 1. 1 over 12 is between 0 and 1. And the sum of total probability, if I add them up, 1 over 12 plus 1 over 12 plus 1 over 12, 12 times is 1. So that verifies this is a probability. This is the joint probability function of x and y. Next example, when two dice are rolled at the same time, let the random variable x represent the value shown on the first die, and let the random variable y represent the maximum value shown on the dice. Part A, find the joint probability function. Part B, find each of the following probabilities. Probability that x is 2, y is 5. Probability that x is 3, y is 2. Probability that x is 4, y is 4. Probability that x is 5, y is 6. So let's do part A first. Find the joint probability function. So in order to find the joint probability function, if the sample space is not too big, let's find the sample space first. If the sample space is not too big, let's find the sample space first. How does the sample space looks like? How does the sample space looks like? When we roll a die, outcome could be either 1, 2, 3, 4, 5, or 6. When we roll the second die, outcome could be either 1, 2, 3, 4, 5, or 6. So the outcome could be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Those are sample space. That's a sample space. Next, find x and y value for each sample point. Find x and y value for each sample point. For the sample point 1, 1, x represents the value shown on the first die, so s is 1. Y represents the maximum value shown on the die. For 1 and 1, maximum value is 1. So s is 1, y is 1. For the next sample point, x represents the value shown on the first die. S is 1. Y represents the maximum value shown on the dice. For 1 and 2, maximum value is 2. For 1, 3, S is 1, Y is 3, Y is the maximum. S is 1, Y is 4. Next one, S is 1, Y is 5. Last one, S is 1, Y is 6. Those are capital S and Y's. Next, for the sample point 2, 1, x represents the value shown on the first die, so s is 2. Y represents the maximum value shown on the dice. For 2 and 1, the maximum value is 2. Next, s is 2. Y is the maximum value shown on the dice, so y is also 2. Y is the maximum value. For 2 and 2, the maximum value is 2. Next, s is 2. S is the value shown on the first die. What's y here? Y is the maximum value shown on the die. So y here is 3. S is 2. Y is 4. Y is the maximum value. And s is 2. Y is 5. S is 2. Y is 6. Next row. For the sample point 3, 1, x is the value shown on the first die, so s is 3. What's y? Y is the maximum value shown on the die. Maximum value shown on the dice. For 3 and 1, maximum value is 3. X is 3. Y is also 3. Y is the maximum value between 3 and 2, which is 3. S is 3. Y is 3. S is 3. Y is 4. S is 3. Y is 5. S is 3. Y is 6. Next, for the sample point 4, 1, x is the number shown on the first die, which is 4. Y is the maximum value shown on both dice. For 3 and 1, maximum value is 4. Sorry, for 4 and 1, maximum value is 4. For the sample point 4, 2, s is 4. Y is the maximum value, so y is 4. S is 4, y is 4. S is 4, y is 4. S is 4, y is 5. Y is the maximum value shown on the dice. Maximum value here is 5. S is 4, y is 6. Next row. For the sample point 5, 1, s is 5. Y is the maximum value shown on the dice, so y is also 5. S is 5. Y is 5. Y is the maximum value shown on the die. S is 5. Y is 5. S is 5. Y is 5. Y is the maximum value. For 5 and 4, maximum value is 5. S is 5. Y is 5. x is 5, y is 6. Y is the maximum value shown on the die. Next, x is 6, y is 6. X is 6, y is 6. Y is the maximum value. The maximum value between 6 and 2 is 6. X is 6, y 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 is 6. Next, find the support. Based on the sample space, find the support. Support of x represents the set of all possible values that x could be. X represents the value shown on the first die. The value shown on the first die could be either 1, 2, 3, 4, 5, or 6. So support of x is the numbers from 1 to 6. What's support of y? Support of y represents the set of all possible values that y could be. Y represents the maximum value shown on the dice. Y could be 1, 2, 3, 4, 5, 6. Y won't be more than 6. So y is also integers from 1 to 6. Next, we can find the joint probability function. For the joint probability function, I can write it as a table. Put a set of all possible x value in the first column. Put a set of all possible x value in the first column. X could be 1, 2, 3, 4, 5, 6. Next, put a set of all possible y value in the first row. Y could be 1, 2, 3, 4, 5, or 6. Next, we find a probability for each of them. There are totally 36 outcomes. The probability for each of them is the same. When s is 1, y is 1. We only have one outcome here. So the chance is 1 over 36. When s is 1, y is 2. We have one outcome out of 36. S is 1, y is 2. We have one outcome out of 36. When s is 1, y is 3. We have one outcome out of 36. And same thing, when s is 1, y is 4. We have one outcome out of 36. One outcome out of 36. One out of 36. Next row. When s is 2, y is 1. When s is 2, y is 1, it doesn't exist here. When s is 2, y is 1, it doesn't exist here. So the chance is 0. Next, when s is 2, y is 2. When s is 2, y is 2, we have two outcomes out of 36. When s is 2, y is 2, we have two outcomes out of 36. When s is 2, y is 3, we have one outcome out of 36. When s is 2, y is 4, we have one outcome out of 36. When s is 2, y is 5, we have one outcome out of 36. Same thing, 1 out of 36. Next row. When s is 3, y is 1. When s is 3, y is 1. It does not exist. When s is 3, y won't be 1. It does not exist. When s is 3, y is 2. Also, it does not exist. When s is 3, y is 3. We have 1, 2, 3. We have 3 outcomes out of 36. Next, when S is 3, Y is 4. We have 1 outcome out of 36. When S is 3, Y is 5. We have 1 out of 36. X is 3, Y is 6. We have 1 out of 36. Next row. When S is 4, Y is 1. It doesn't exist here. That's 0. When S is 4, Y is 2. When the first die showing 4, maximum won't be 2. When the value shown on the first die is 4, the maximum won't be 2. That's 0. When the value shown on the first die is 4, maximum won't be 3. The chance is 0. When S is 4, Y is 4. We have 1, 2, 3, 4. There are 4 outcomes. It's 4 out of 36. When S is 4, Y is 5. We have 1 outcome out of 36. S is 4, Y is 6. It's 1 out of 36. Next row. When S is 5, Y is 1. When the value shown on the first die is 5, the maximum won't be 1, so that's impossible. When the maximum shown on the first die is 5, when the value shown on the first die is 5, maximum won't be 2. When the value shown on the first die is 5, maximum won't be 3. It won't be 4, but it could be 5. If the maximum is 5, we have 1, 2, 3, 4, 5. 5 outcome out of 36. And when S is 5, Y is 6, we have 1 outcome out of 36. Last row. S is 6, Y is 1. Is it possible? If the value shown on the first die is 6, can the maximum be 1? If the value shown on the first die is 6, can the maximum be 1? That's impossible. Maximum won't be 2, maximum won't be 3, maximum won't be 5, maximum won't be 6. When S is 6, Y is 6, we have 6 outcomes out of 36. That's the joint probability function of X and Y. That's the joint probability function of X and Y. We can check the answer. If I add everything in the first row together, that's 6 over 36. If I add all probability in the second row together, it's also 6 over 36. If I add all probability in the third row together, it's also 6 over 36. If I add all probability in the fourth row together, it's 6 over 36. If I add all probability in the fifth row together, it's also 6 over 36. If I add the probability in the last row together, it's 6 over 36. Together we have 6, 6, 6, 6, 6, 6. 6 times 6 is 36. 36 over 36 is 1. So the total probability is 1. That verifies this is a probability function. This is a joint probability function. That's part A. Now part B. Part B. Find each of the following probabilities. Find each of the following probabilities. Probability that S equal to 2, Y equal to 5. That's f of 2 comma 5. When S is 2, Y is 5, the probability is 1 over 36. Find the probability that S equal to 3, Y equal to 2. That's f of 3 comma 2. That's f of 3 comma 2. S is 3, Y is 2. Chance is 0. Next, find the probability that S is 4, Y is 4. That's f of 4 comma 4. That's f of 4 comma 4. When S is 4, Y is 4. Probability is 4 over 36. Last one. Probability that S equal to 5, Y equal to 6. That's f of 5 comma 6. When S is 5, Y is 6. The chance is 1 over 36. Next example. In the bag, there are 5 blue marbles, 7 green marbles, and 8 red marbles. when 3 marbles are randomly chosen, let X represent the number of chosen blue marbles, and let Y represent the number of chosen red marbles. Part A. Find the joint probability function. Part B. Find each of the following probabilities. Probability that x equal to 1, y equal to 1. Probability that x equal to 2, y equal to 2. Probability that x equal to 0. Probability that y equal to 2. Probability that x equal to y. Probability that x equal to 0 given that x equal to y. Let's do part A first. Find a joint probability function. In order to find a joint probability function, let's find a sample space first. There are totally 5 plus 7 plus 8, there are totally 20 marbles. And we are choosing 3 marbles out of 20. How big is the sample space? Sample space represents the set of all possible outcomes. In how many ways can we choose 3 marbles out of 20? The number of ways to choose 3 marbles out of 20 is 20 choose 3, combination 20 choose 3. I use my calculator, I get 1140. That means in the sample space, there are 1140 elements. The sample space is too big. It's almost impossible for us to write down the sample space. So let's try to find the joint probability function without using the sample space. For this problem, let's try to find the joint probability function without using the sample space. Let's find the support first. What's the support of x? X represents the number of chosen blue marbles. Since we are choosing 3 marbles out of 20, we may have 0 blue marble, 1 blue marble, 2 blue marble, at most 3 blue marble. Y represents the number of red marbles, so support of y represents a set of all possible values that y could be. We may have 0 red marble, 1 red marble, 2 red marble, at most 3 red marble. Now, for the joint probability function, put x in the first column, put y in the first row. X could be 0, 1, 2, 3. Y could also be 0, 1, 2, 3. Let's try to find a probability for each of them. When x is 0, y is 0, means we are choosing 0 blue marble and 0 red marble. If we are choosing 0 blue marble and 0 red marble, we must get 3 green marbles. We must have 3 green marbles. So the number of ways of choosing 0 blue marble is 5 choose 0. The number of ways of choosing 3 green marble is 7 choose 3. The number of ways of choosing 0 red marble is 8 choose 0. Divided by the number of all possible outcomes. Probability is always number of available outcomes divided by number of all possible outcomes. That's 20 choose 3. Next, when x is 0, when y is 1, it means we are choosing 0 blue marble, 1 red marble. We must have 2 green marbles since we are choosing 3 marbles. If we have 0 blue marble, 1 red marble, we must have 2 green marbles. 5 choose 0, 7 choose 2, 8 choose 1. Over 20 choose 3. When x is 0, y is 2. That means we are choosing 0 blue marble, 2 red marble. That means we must have 1 green marble. So we have 5 choose 0, 7 choose 1, 8 choose 2. Over 20 choose 3. That's the number of all possible outcomes. When x is 0, y is 3. Means we are choosing 0 blue marble, 3 red marble. Since we're choosing totally three marbles, if we have 3 red marble, we must have 0 green marbles. So the number of way of choosing the marbles is 5 choose 0, 7 choose 0, 8 choose 3. Over 20 choose 3. Next row. When S is 1, Y is 0, means we are choosing 1 blue marble, 0 red marble. If we choose 1 blue marble, 0 red marble, we must have 2 green marbles because we are choosing a total of 3 marbles. So the numerator number of available outcome is 5 choose 1, 7 choose 2, 8 choose 0. Over 20 choose 3. Next, when S is 1, Y is 1, that means we are choosing 1 blue marble, 1 red marble. Since we are choosing a total of 3 marbles, if we choose 1 blue marble, 1 red marble, we must choose 1 green marble. So we have 5 choose 1, 7 choose 1, and 8 choose 1. Over 20 choose 3. Next, S is 1, Y is 2, means we are choosing 1 blue marble and 2 red marble. Since we are choosing a total of 3 marbles, then we must have 0 green marbles. So we have 5 choose 1, 7 choose 0, 8 choose 2. Over 20 choose 3. Next, when S is 1, Y is 3, that means we are choosing 1 blue marble and 3 red marble. Since we are choosing a total of 3 marbles, we can have 1 blue marble and 3 red marble. That's impossible. Next row. S is 2, Y is 0. That means we are choosing 2 blue marble and 0 red marble. Since we are choosing a total of 3 marbles, we must have 1 green marbles. So we have 5 choose 2 times 7 choose 1 times 8 choose 0. Over 20 choose 3. Next, S is 2, Y is 1, means we are choosing 2 blue marble, 1 red marble. Since we are choosing a total of 3 marbles, if I choose 2 blue marble, 1 red marble, I must have 0 green marbles. So 5 choose 2, 7 choose 0, times 8 choose 1. Over 20 choose 3. Next, S is 2, Y is 2, means we are choosing 2 blue marble and 2 red marble. That's impossible. We only choose 3 marbles. We can't have 2 blue marble and 2 red marble at the same time. That's impossible. Next, S is 2, Y is 3. We choose 2 blue marbles and 3 red marbles at the same time. That's also impossible. Next row. We are choosing S is 3, Y is 0. That means we are choosing 3 blue marbles and 0 red marbles. Since we choose a total of 3 marbles, if I choose 3 blue marble, I must have 0 green marble and 0 red marbles. Over 20 choose 3. 5 choose 3, 7 choose 0, 8 choose 0. Over 20 choose 3. Next, S is 3, Y is 1. That means we are choosing 3 blue marbles and 1 red marble. That's impossible because we are choosing a total of 3 marbles. We can't have 3 blue marble and 1 red marble at the same time. And similarly, we can't have 3 blue marble and 2 red marble at the same time. Similarly, we can have 3 blue marble and 3 red marble at the same time. That's also 0. Next, we must calculate each of them. Calculate each probabilities. Next, I use my calculator. I calculate each probabilities. Then I have a new table here. This is the joint probability function of x and y. If we want to check the answer, we can add all these probabilities together. The total probability must be 1. That's part A. Part B. Find each of the following probabilities based on part A. Find each of the following probabilities based on part A. First one, probability that x equal to 1, y equal to 1. probability that x equal to 1, y equal to 1. That's f of 1, comma 1. F of 1, comma 1. S is 1, y is 1. When s is 1, y is 1, we have 280 over 1140. If we simplify, I get 14 over 57. Next, find the probability that x equal to 2, y equal to 2. That's f of 2, 2. F of 2, comma 2. When s is 2, y is 2, the probability is 0. Next, find the probability that s equal to 1. Find the probability that s equal to 0, sorry. Find the probability that s equal to 0. When s equal to 0, that means y could be any number. So it could be 0, comma 0, plus 0, comma 1, plus 0, comma 2, plus 0, comma 3. When s is 0, y could be any number. Y could be 0, 1, 2, 3, 0, 1, 2, or 3. Y could be 0, 1, 2, or 3. Y could be any number. Then adding up. S is 0, y is 0. We have 35 over 1140. S is 0, y is 1. We have 168 over 1140. 0, comma 2. That's 196 over 1140. When s is 0, y is 3, we have 56 over 1140. Then adding up, I have 455 over 1140. If I simplify the answer, I get 91 over 228. That's probability that s equal to 0. We must consider all possible y values. Y could be 0, 1, 2, 3. When s is 0, we must consider all possible y values. Y could be 0, 1, 2, 3. Then we find probability of f0, 0, f of 0, comma 1, 0, comma 2, 0, comma 3. Then adding up. That's the probability that s equal to 0. Next, find the probability that y equal to 2. When y equal to 2, s could be any numbers. S could be 0, 1, 2, or 3. So we have 0, comma 2, f of 1, comma 2, plus f of 2, comma 2, plus f of 3, comma 2. When y is 2, s could be 0, 1, 2, and 3. Then adding up. F of 0, comma 2 is 196 over 1140. F of 1, comma 2 is 140 over 1140. Next, for f of 2, comma 2, s is 2, y is 2, we have 0. F of 3, comma 2, s is 3, y is 2, we have probability 0. Adding up, we have 336 over 1140. Then use calculator, I get 28 over 95. Next, find the probability that s equal to y. Find the probability that s equal to y. Probability that s equal to y. When s equal to y, it could be f of 0, 0, plus f of 1, 1, plus f of 2, 2, plus f of 3, 3. When s equal to y, it could be s and y they're both 0, s and y they're both 1, they're both 2, or they're both 3. Adding up. If they're both 0, we have 0, 0, 35 over 1140. F of 1, comma 1, we have 280 over 1140. F of 2, comma 2 is 0. F of 3, comma 3 is also 0. Adding up, I use my calculator, I get 315 over 1140. That can be reduced as 21 over 76. Next, what's the probability that x equals 0 given that x equals y? What's the probability that x equals 0 given that x equals y? This is the conditional probability. This is the conditional probability. The denominator is a condition, probability that x equal to y. For numerator, we must consider the intersection, probability that x equal to 0 and x equal to y. The denominator, probability that x equal to y, we have it here. For the numerator, probability that x equal to 0 and x equal to y, that's the probability x equal to 0 and y equal to 0. Probability that x equal to 0 and x equal to y, that's the probability that x equal to 0 and y equal to 0. So the numerator, probability that x equal to 0, y equal to 0, that's 35 over 1140. For the denominator, probability that x equal to y, we just found it here. That's 21 over 76. Or we can use 315. Over 1140. If we reduce it, we can cancel the denominator. We get 35 over 315, which is 1 over 9. Next example, Jerry is a student. He has 3 homework assignments every week, and he has a weekly quiz with a total of 5 points at the end of each week. Let X represent the number of homework assignments completed by Jerry in a week, and let Y represent Jerry's weekly quiz score. Here, X and Y, they are discrete random variables. The joint probability function of X and Y is given below. This is the joint probability function of X and Y. Part A. What's the probability that Jerry completes 2 assignments in a week and he failed the quiz? If a quiz score is 3 points or below, it's considered a failing grade. Part B. What's the probability that Jerry passes a weekly quiz? Part C. What's the probability that Jerry completes at least 2 assignments in a week? Part D. If it's known that Jerry completes only 1 assignment in a week, what's the probability that Jerry will fail the weekly quiz? Part E. If it's known that Jerry scores 4 points in a weekly quiz, what's the probability that he completes more than 1 assignment in a week? Let's answer these questions based on the joint probability function. Let's answer these questions based on the joint probability function. First step, let's write down the support first. What's support of X? What's support of Y? Write down the support first. Support represents the set of all possible values that X could be. Support of X is the set of all possible values that X could be. Here X could be 0, 1, 2, 3. That means Jerry may complete 0 assignments, 1 assignment, 2 assignments, or 3 assignments. So support of X is 0, 1, 2, 3. That means Jerry may complete 0 assignments, 1 assignment, 2 assignments, or 3 assignments. Next, what's support of Y? Support of Y is the set of Y, the set of Y values. The set of values that Y could be. The set of all possible values that Y could be. Y represents Jerry's quiz score. Y represents Jerry's quiz score. So Jerry may get 0 points, 1 point, 2 points, 3 points, 4 points, at most 5 points. So Y represents Jerry's quiz score. Jerry may get 0 points, 1 point, 2 point, 3 point, 4 point, and a maximum of 5 points in a quiz. That's support of X and Y. Now let's answer the question. Part A. What's the probability that Jerry completes 2 assignments in a week and he fails the quiz? If Jerry completes 2 assignments, that means S equal to 2. X represents number of homework assignments completed by Jerry. If Jerry completed 2 assignments, X equal to 2. And he failed the quiz. If Jerry failed the quiz, that means he scores 3 points or below. So Y is less than or equal to 3. He scores 3 points or below. So let's write down all possibilities here. S is 2, Y is less or equal to 3. So when S is 2, support of Y is from 0 to 5. So if Y is less or equal to 3, Y could be 0, 1, 2, 3. If Y is less or equal to 3, Y could be 0, 1, 2, 3. When S is 2, Y could be 0. When S is 2, Y could be 1. When S is 2, Y could be 2. And when S is 2, Y could be 3. S equal to 2, Y is less or equal to 3. Then find the value from the table. F of 2 comma 0, S is 2, Y is 0, I get 0.1. So I get 0.01. F of 2 comma 1, S is 2, Y is 1, I get 0.03. F of 2 comma 2, S is 2, Y is 2, I get 0.04. Next, F of 2 comma 3, that means when S is 2, Y is 3, I get 0.05. Add it up, I get 0.13. That's the probability that Jerry completed 2 assignments in a week and he failed the weekly quiz. That's the probability that Jerry completed 2 assignments in a week and he failed the weekly quiz. Probability is 0.13. Part B. What's the probability that Jerry passed the weekly quiz? What's the probability that Jerry passed the weekly quiz? If Jerry passed the weekly quiz, means his quiz score is above 3. That means it's either 4 or 5. His quiz score is above 3. If Jerry passed the quiz, his quiz score is above 3. If his quiz score is above 3, it could be either 4 or 5 because support of Y is from 0 to 5. If Jerry passed the quiz, his quiz score could be either 4 or 5. And this doesn't specify X. X could be either 0, 1, 2, 3. Jerry may complete 0 assignments but pass the quiz. He may complete 1 assignment but pass the quiz. 2 assignments, pass the quiz. Or complete 3 assignments or pass the quiz. So let's write down all possibilities. It's possible that Jerry scored 0 points and Jerry complete 0 assignment and score 4 points on the quiz. It's possible that Jerry complete 1 assignment and score 4 points. Or Jerry complete 2 assignments, score 4 points. Jerry complete 3 assignments, score 4 points. Or it's possible that Jerry complete 0 assignment and score 5 points. Or he scored 2 points. He complete 1 assignment, he complete 1 assignment, score 5 points. Or he complete 2 assignments and score 5 points. Or he complete all 3 assignments, score 5 points. That's all possibilities. In the first row, it represents all probability that Jerry scored 4 points. Second row represents all probability that Jerry scored 5 points. If Jerry scored 4 points, he may complete 0 assignment, 1 assignment, 2 assignment, 3 assignments. If Jerry scored 5 points, he may complete 0 assignment, 1 assignment, 2 assignment, or 3 assignment. Those are all possibilities. Then, find the probability from the table and add it up. F of 0, 4. 0, 4 here is 0.05. F of 1, 4. 1, 4 is 0.04. F of 2, 4. 2, 4 is 0.04. f of 3 comma 4. X is 3, y is 4. That's 0.03. Plus next row, f of 0 comma 5. 0 comma 5 is 0.03. F of 1 comma 5. F of 1 comma 5 is 0.03. Next, f of 2 comma 5. F of 2 comma 5 is 0.03. Last one, f of 3 comma 5. F of 3 comma 5 is 0.02. Adding up, it's 0.16 plus 0.11. Together is 0.27. That's the probability that Jerry passed the quiz. That's the probability that Jerry will pass the weekly quiz. Part C. Part C. What's the probability that Jerry complete at least 2 assignments in a week? Part C. What's the probability that Jerry complete at least 2 assignments in a week? X represents number of complete assignments by Jerry. So if Jerry complete at least 2 assignments, means he complete 2 or more assignments. If Jerry complete at least 2 assignments, means Jerry complete 2 or more assignments. Support of x is from 0 to 3. So if s is greater than or equal to 3, s could be either 2 or 3. S could be either 2 or 3. And here it doesn't specify y. So y could be everything. Y could be 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, or 5. Could be anything. So it's possible that Jerry complete 2 assignments, he scored 0 points. He complete 2 assignments, score 1 point. Complete 2 assignments, score 2 points. Complete 2 assignments, score 3 points. Complete 2 assignments, score 4 points. Or complete 2 assignments, score 5 points. But are all possibilities. Or it's possible that he completes 3 assignments, but he scored 0 points. He completes 3 assignments, score 1 point. 3 assignments, complete 2 points. 3 assignments, score 3 points. He completes 3 assignments, score 4 points. Or he completes 3 assignments and score 5 points. We must include all possibilities. So s is greater or equal to 3. Greater or equal to 2. When s is 2, y could be 0. When s is 2, y could be 1. When s is 2, y could be 2. When s is 2, y could be 3. When s is 2, y could be 4. When s is 2, y could be 5. Or it's possible that Jerry completes 3 assignments, but he scored 0 points. He completes 3 assignments, score 1 point. Completes 3 assignments, score 2 points. Completes 3 assignments, score 3 points. Or he completes 3 assignments, score 4 points. Or complete 3 assignments, score 5 points. Find all probabilities adding up. Find all probabilities and adding up. F of 2 comma 0 is 0.01. F of 2 comma 1 is 0.03. F of 2 comma 2 is 0.04. F of 2 comma 3 is 0.05. F of 2 comma 4 is 0.04. F of 2 comma 5 is 0.03. That's the first row. That's all probability in the first row. Second row, if Jerry scores 3 points, if Jerry completes 3 assignments, he may score 0, 1, 2, 3, 4, 5 on the quiz. Let's write down all probabilities. f of 3 comma 0 is 0.01. F of 3 comma 1 is also 0.01. F of 3 comma 2 is also 0.01. F of 3 comma 3 is 0.02. F of 3 comma 4 is 0.03. F of 3 comma 5 is 0.02. Then adding up. If I add the first parentheses, I have 0.20. If I add the second parentheses, I have 0.10. I get 0.10. 0.20 plus 0.10 is 0.30. So that's the probability that Jerry will complete at least 2 assignments in a week. That's the probability that Jerry will complete at least 2 assignments in a week. Now, part D. If it's known that Jerry completes only 1 assignment in a week, what's the probability that Jerry will fail the weekly quiz? This is conditional probability. If we know some given condition, this is conditional probability. If it's known that Jerry completes 1 assignment in a week, what's given is that Jerry completes only 1 assignment in a week. What's given is that Jerry completes only 1 assignment in a week. S equal to 1. That's what's given. Jerry completes only 1 assignment in a week. What's the probability that Jerry will fail the quiz? If Jerry fails the quiz, means he score 3 or below. If Jerry fails the quiz, means he scores 3 or below. So y is less than or equal to 3. Y represents Jerry's quiz score. So if Jerry fails the quiz, means y is less than or equal to 3. So let's write down the conditional probability. The numerator is probability that s equal to 1 and y less or equal to 3. The denominator is probability that s equal to 1. Let's find each probability individually and then divide. Let's find each probability individually and then divide. Let's find the numerator first. Probability that s equal to 1 and y is less or equal to 3. That's the numerator. Probability that s equal to 1 and y is less or equal to 3. Since support of y is from 0 to 5, if y is less or equal to 3, y could be 0, 1, 2, 3. S is 1, y could be 0, 1, 2, 3. It could be f of 1, 0, f of 1, 1, 1, f of 1, 2, plus f of 1, 3. Then for the probabilities and adding up, f of 1, 0 is 0.03. F of 1, 1 is 0.06. F of 1, 2 is 0.08. F of 1, 3 is 0.06. Adding up, we get 0.23. That's the numerator. For the denominator, find the probability that s equal to 1. When s equal to 1, y could be any number. Support of y is from 0 to 5. So when s is 1, y could be 0, 1, 2, 3, 4, or 5. So when s is 1, y could be any numbers in the support. That's f of 1, 0 plus f of 1, 1 plus f of 1, 2 plus f of 1, 3 plus f of 1, 4 plus f of 1, 5. Then find the probabilities from the table and adding up. Find the probabilities from the table and then adding up. F of 1, 0 is 0.3. f of 1 comma 1 is 0.06, f of 1 comma 2 is 0.08, f of 1 comma 3 is 0.06, f of 1 comma 4, f of 1 comma 4 is 0.04. Last one, f of 1 comma 5 is 0.03. Then adding up, we have 0.30. So for the conditional probability, y less or equal to 3 given that s equal to 1, let's probability that s equal to 1, y less or equal to 3 over probability that s equal to 1, which is 0.23 over 0.30, which is 23 over 30. That's the probability that Jerry complete only one assignment and fail the quiz. That's the probability that Jerry complete only one assignment and he failed the quiz. Part E. If it's known that Jerry scored 4 points in a weekly quiz, what's the probability that he complete more than one assignment in a week? If it's known that Jerry scored 4 points in a weekly quiz, what's the probability that he complete more than one assignment in a week? So this is also conditional probability. Some condition is given. So if it's known that Jerry scored 4 points in a weekly quiz, you already present Jerry's quiz score. Here, what's given is that Jerry scored 4 points in a weekly quiz. Jerry scored 4 points in a weekly quiz. What's the probability that he complete more than one assignment in a week? What's the probability that he complete more than one assignment in a week? We're looking for probability that he complete more than one assignment. S is greater than 1. He complete more than one assignment in a week. This is the conditional probability. Let's use a formula for conditional probability. That's the probability that x is greater than 1, y equal to 4. Over denominator, probability that y equal to 4. Let's find each probability individually and then divide. Let's find each probability individually and then divide. Let's find the numerator first. What's the probability that s is greater than 1 and y equal to 4? When s is greater than 1, since the power of x is 0, 1, 2, 3, if s is greater than 1, s could be 2 or 3. So we must consider both possibilities. S could be either 2 or 3. So we have f of 2, 4 plus f of 3, 4. F of 2, 4 from the table we know that f of 2, 4 is 0.04. F of 2, 4 is 0.04. F of 3, 4. F of 3, 4 is 0.03. F of 3, 4 is 0.03. Adding up, we get 0.07. That's the numerator, probability that s greater than 1 and y equal to 4. Next, let's find the denominator. What's the probability that y equal to 4? What's the probability that y equal to 4? When y equal to 4, s could be anything in the support. When y equal to 4, s could be anything. Here, x in the support has 0, 1, 2, 3. So in the support, s could be 0, 1, 2, or 3. We must consider all possibilities. When y is 4, s could be 0, 1, 2, 3, 4. 0, 1, 2, 0, 1, 2, and 3. So s could be 0, s could be 1, s could be 4, s could be 2, s could be 3, y is always 4. Then find the probabilities and adding up. F of 0, 4, find it from the table. F of 0, 4 is 0.05. F of 1, 4 is 0.04. F of 2, 4 is 0.04. f of 3 comma 4 is 0.03. Adding up, we get 0.16. Then for the conditional probability, we plug in all the values. S is greater than 1 given that y equal to 4. The numerator is probability that s greater than 1, y equal to 4. The denominator is probability that y equal to 4. Plug in the values. The numerator is 0.07. Denominator is 0.16. If we simplify, we get 7 over 16. If we simplify, we get 7 over 16. That's the probability that if it's known Jerry scored 4 points in the quiz, that's the probability that he completed more than one assignment.